Good afternoon, everyone. In the last class, we discussed about the venturimeter, right? So, the design of expression for discharge through the venturimeter. So, we discussed the equations for venturimeter discharges or theoretical discharge and actual discharges, or for theoretical discharge, the equation will be A1 A2 into root 2ch by root of A1 square minus A2 square, right? So here A1 is the area of the inlet and A2 is the area of throat. And here H is nothing but head of the water which was flowing through the pipe. And of course, to calculate the value of H, we have another formula, that is H is equals to X into SH by S1 minus 1, where X is the difference in the mercury levels or manometer levels, and SH is the specific gravity of heavier liquid in manometer, and SO is the specific gravity of liquid which was flowing through the pipe. Using the specific gravity values and using the differences between these manometer readings, we can get the head of water which was flowing through the pipe. And using these values, we can calculate the theoretical discharge, and after calculating the theoretical discharge, we can calculate the actual discharge by using the formula coefficient of discharge into the theoretical discharge. And usually, the coefficient of discharge can be taken as with a range of in between 0.98 to 0.99, right? So that is about the equations, and of course we have discussed some of the problems regarding this venturimeter also, right? So let's discuss some more problems related to this. Look at the problem. So I'm going to read the problem. The problem is the inlet and throat diameters of a horizontal venturimeter are 30 centimeter and 10 centimeters. The liquid flowing through the meter is water. The pressure intensity at the inlet is 13.734 Newton per centimeter square, while the vacuum pressure head at the throat is 37 centimeters of mercury. Then find the rate of flow. Assume that 4% of the differential head is lost between the inlet and throat. Find also the value of coefficient of discharge for the venturimeter, right? So this is the biggest problem. If you know this one, then you can solve any problem regarding the venturimeter. So I'm reading the problem once again. Listen this carefully. The inlet and throat diameters of a horizontal venturimeter. So here the given venturimeter is a horizontal one, and for this the inlet diameter, the D1 is given as 30 centimeters, and outlet diameter D2 is given as, outlet means the throat. The throat diameter is given as 10 centimeters, and they said the liquid which was flowing through the pipe is water. So the lighter liquid is water. Then the pressure intensity at the inlet P1 is given as 13.734 Newton per centimeter square, and then the vacuum pressure at the throat and P2 pressure at second section P2 is given as 37 centimeters. No, they have given the pressure head, not the pressure. They have given the pressure head at the throat. At the throat means that is at section 2. The pressure head means the expression P2 by rho z. For at the inlet, they have given pressure P1 only, and at the section 2 at the throat, they have given pressure head, that is P2 by rho z. So section 1 దగ్గర P1 మాత్రమే ఇచ్చారు, section 2 దగ్గర pressure head directly P2 by rho z value ఇచ్చేసారు, and the value is given as 37 centimeters of mercury. So they have given in terms of mercury, so that we should convert into water. Then so using these values, we should find out the rate of flow, that is the discharge. And to find out the discharge, they have given a condition that assume that 4% of differential head is lost between inlet and throat. So there might be some head loss was taking place, and that head loss is 4% of the differential head. During the total head, 4% of lost between inlet and throat from section 1 to section 2, 4% of the head was lost. And also we should calculate the coefficient of discharge for the venturimeter. So using all these values, we should calculate the discharge as well as we should calculate the coefficient of discharge also. Is it clear about the problem? So firstly, we should write the given data. So let's take the given data. The given data is the inlet diameter D1 is 30 centimeters, and from there the area at the inlet is pi D1 square by 4, and the value 706.85 centimeters square. Then diameter at the throat is given as 10 centimeters, that is at section 2 D2. Then area will be pi D2 square by 4. And then they have given the pressure intensity at the inlet. The pressure intensity at the inlet P1 is given as 13.734 Newton per centimeter square. So to convert the value into meter square, we should multiply with 10 power 4, isn't it? So already you know how to multiply this one, how to get this value, isn't it? So that is the value for P1. Then let's calculate the pressure head at section 1, that is P1 by rho g. So pressure is P1 and pressure head is P1 by rho g. That's what we learned from the Bernoulli's equation. You know that, right? So pressure head from the Bernoulli's equation, pressure head P1 by rho g, velocity head V1 square by 2z or V square by 2z, and atom head Z, as you know. So to convert the pressure from pressure head, then we can use the formula as P1 by rho g. So simply we are going to divide the pressure value with density and this acceleration due to gravity. So the value will be 13.734 into 10 power 4 by the density of mass density of the water. Why? Because they are given the flowing liquid is water. So we are taking mass density of water is 1000, and the acceleration due to gravity value in terms of meter per second square is 9.81 meter per second square. So substituting the values, we can get the pressure head as 14 meters of water. The head is meters, the pressure is in Newton per meter square. You should know the difference, right? And then they have given vacuum pressure. So vacuum pressure at the throat or at the section 2, that is P2 by rho g, and which is given as the value is given as 37 centimeters of mercury. So in the problem, they have given vacuum pressure. As you know that, so we have different types of pressures. You know that already, isn't it? So what are the different types of pressures? Atmospheric pressure, positive like gas pressure, vacuum pressure or the suction pressure, and then absolute pressure. I think you remember those pressures, isn't it? So the very first one is atmospheric pressure, then gas pressure, and then vacuum pressure, and then finally the absolute pressure. And the vacuum pressure is having the another name, that is negative pressure. Suppose మీకు ఎప్పుడైనా సరే ప్రాబ్లంలో vacuum pressure అని ఇస్తే you should take the value as a negative value, right? Always you should take the value as a negative value. Why? Because vacuum pressure is a negative pressure, so that we should take that value as a negative value. Vacuum pressure is also called as the negative pressure. That's why the vacuum pressure head, they have given the vacuum pressure head, the value is given as 37 centimeters of mercury. As the pressure is vacuum pressure, and we can call that also as the negative pressure, so we are taking the value as negative, that is minus 37 centimeters of mercury. Do you understand why we have taken the minus value? Why? Because the vacuum pressure is also called as the negative pressure. So that's why in the problem, if they have given the pressure as a vacuum pressure, then we should take the value as negative value, right? So the P2 by rho g value is taken as minus 37 centimeters of mercury. Problem lo vallu ivaru, just vacuum pressure ani chepte directly you should take the value in terms of negative, right? Problem lo positive gaane istaru, but you should take it as a negative one. Then to convert this value, to convert the value from mercury to water, so we are going to multiply with the specific gravity, as you know, isn't it? So to convert from mercury to water, we should multiply with the specific gravity of mercury. Then it will be 37 centimeters into 13.6. So to convert the centimeters, we should divide with 100. Why? Because 1 meter is equals to 100 centimeters. So that's why we are dividing it with 100. then it will be the value for vacuum pressure in terms of water as minus 5.032 meters of water. So to convert from mercury to water, always we should multiply with the specific gravity, so that the pressure head will be the given value, given negative value multiplied with 13.6. And to convert the centimeters into meters, we are going to divide with 100. So this is the pressure head which was obtained in terms of water. And now let's calculate the differential pressure head from section 1 to section 2. So we know the differential pressure head equation, that is H equals to P1 by rho z minus P2 by rho z, isn't it? You know that. So while deriving that equation, already you have gone through about this differential head, that is H is equals to P1 by rho z minus P2 by rho z. So we have calculated the pressure head at section 1 as 14 meters, and we have calculated the pressure head at section 2 in terms of water as minus 5.032. So substituting the values, 14 minus of 5.032, we can get the differential head which was flowing through the water, which was flowing through the pipe as 19.032 meters of water. And converting into centimeters, we are going to multiply with 100, then the value will be 1903.2 centimeters. And they said that there is some head was lost during the flow of water, and the loss of head may be 4% from the total head, right? The loss of head may be 4% from the total head. So we can calculate the head loss by HF is equals to 4% of the total head. Then it will be 4 by 100 into the total head is 19.032 meters. So the head loss which was taking from the total head is given as 0.7613 meters. Okay, so that's what they have given in the problem. So they said that the head loss from the total head is 4%. So we have calculated the total head, and in the total head, the head loss is 4% only. So the value we can calculate as 4% of the total head, which is equals to 4 by 100 into the total head 19.032. So the loss of head which was occurred on the total head is 0.7613 meters only. Now we can calculate the coefficient of discharge. Of course, to calculate the coefficient of discharge, we have one more formula. 1 second. That is CD is equals to square root of H minus HF by H. So that is nothing but output by input. So square root of output by input. Then it will be substituting the values. So we can get root of 19.032 minus 0.7613 by 19.032. And we get the coefficient of discharge for the given venturi meter is 0.98 only. Right? So like this, we can calculate the coefficient of discharge if they have not given the value in the problem. Problemలో మీకు coefficient of discharge value ఇవ్వకపోతే you can calculate the coefficient of discharge by using this one. Okay, suppose if they didn't give any head loss value, in that case you can directly take the value as a H by H, so that the coefficient of discharge will be 1 only, isn't it? So in like that also you can calculate it. But if they have given the head loss as a percentage, in that case you can calculate the coefficient of discharge by using the formula root of H minus HF by H. The formula is root of H minus HF by H. So from there you can calculate the coefficient of discharge value. So now we have all the values, right? The area at inlet area at the throat, the coefficient of discharge also. So and also the head of water which was flowing through the pipe. And now we can calculate the discharge which was flowing through the pipe as Q is equals to coefficient of discharge into the theoretical discharge, that is Q equals to CD into A1 A2 root 2ZH by root of A1 square minus A2 square. So we know the CD value 0.98, and we have calculated the value of A1 in terms of centimeter square and A2 in terms of centimeter square into root of 2 into Z value is 9.81 meter per second square. Converting into centimeters, the value will be 981 centimeter per second square. And multiplying with head in terms of centimeters, 1903 point divided by root of a1 square minus a2 square. So substituting all the values, we can get the discharge value as 0.149 meter cube per second. Right? So is it clear, guys? Do you understand about the problem? Suppose we have all the values. You know how to calculate all the values like the diameter and each and everything, isn't it? So if they have given only the pressure values, then using the pressure, we can calculate the pressure head as a formula of P by rho g. Pressure value is the pressure head calculate cheyachu using P by rho g. And the difference of pressure head from section 1 to section 2, that is P1 by rho g minus P2 by rho g will give the total head which was flowing through the pipe. So this is the problem. Suppose if they have given the pressure values from section 1 to section 2, calculate the pressure head by using P by rho g, that is P1 by rho g and P2 by rho g, and then calculate the head of water. Calculate the head of water which was flowing through the pipe by using the formula P1 by rho g minus P2 by rho g. As we know, P1 by rho g minus P2 by rho g. So this is for the horizontal venturimeter. Suppose if it is an inclined venturimeter, in that case, the head can be calculated by using or by including the datum head also. Then the formula will be P1 by rho g plus Z1 minus of P2 by rho g plus Z1, isn't it? So that is for the inclined venturimeter. Whereas in the horizontal venturimeter, Z1 is equals to Z2 only, isn't it? So we can cancel both and then we can get the head as the P1 by rho g minus P2 by rho g. So using that we can calculate the head. Suppose in the problem if they have given the head loss as a percentage, then the total head loss can be calculated. The head loss can be calculated from the total head. That is, the head loss will be 4% from the total head. Then we can calculate the value as 4 by 100 into the total head, and we can get the head loss. And using this, we can calculate the coefficient of discharge. So to calculate the coefficient of discharge by using the heads, the formula will be coefficient of discharge CD is equals to root of H minus HF by H. Right, the coefficient of discharge is equals to root of H minus HF by H. And from there we can calculate the coefficient of discharge, and using the all values like areas and the heads, we can calculate the coefficient discharge as Q equals to CD into A1 A2 into root 2ZH by root of A1 square minus A2 square. Right? So substituting the values in the formula, we can get the discharge like this. Right? So very, very simple problem. What the thing is, you have to clearly understand the given problem. Problem lo ఏమేమి ఇచ్చాడు, మనం ఎలా calculate చేయాలి, ఏ formulas use చేయాలి. Right? So ఈ values మీకు formulas కనుక clear గా తెలిస్తే, you can solve any problem, isn't it? And also you should remember the given pressure is a gauge pressure or vacuum pressure. Suppose if it is a gauge pressure, then directly you can take the value in terms of positive value. And if they mentioned the pressure as a vacuum pressure, then definitely you have to take the value as a negative. Right? You have to remember that thing also. Okay, guys. So that is regarding the venturimeter or horizontal venturimeter. Do you have any doubts regarding this problem? మీకు ప్రాబ్లం అర్థమైందా ఎలా సాల్వ్ చేయాలని? So if you have any doubts, you can ask me. Any doubts, guys? అర్థమైందా అసలు ప్రాబ్లం ఎలా సాల్వ్ చేయాలి అని?
Yes, madam. అర్థమైంది మేడం.
Give me a reply.
No, అర్థమైంది.
Any doubts? ప్రాబ్లం అర్థమైందా అర్థం కాలేదా? Guys, are you there?
Yes, ma'am.
Yes, madam. అర్థమైంది మేడం.
Okay, ma'am. Okay, fine, guys. So that is about the venturimeter, and in the next class I will discuss about the orifice meter. Why? Because morning నుంచి net use చేస్తూనే ఉన్నాను, so I don't have much data. In the next class we will start orifice meter. Very few members have submitted the assignment. What about remaining? మీకు అవసరం లేదా అసైన్మెంట్ మార్క్స్ 0 వేసేసేనా? Saturday is the last date for assignment. Remember that. So if you don't submit the assignment, simply I will put 0. Okay. Okay, guys. So I'm going to stop the class. Thank you, everyone. You can leave the class now.